Hello everybody and welcome to this month's specifying practice group. With that, I want to hand it over to today's presenters, our co-chairs David Stutzman and Louis Medcalf. David and Louis, over to you.
Well, good morning, everyone.
Good afternoon, or good afternoon.
What? No response. Okay. Yeah, I'm sorry. Yes, Matt has you all muted, and if I did that here to my staff, I would get the obligatory groan. I tend to work in the morning and the afternoon only because it lets me think that I have about 8 more hours to go and hopefully be able to finish everything that I had planned to do during the day. So, welcome everybody, and glad you were able to join us here in December, and despite the fact that it's our holiday month and many of our normal folks may have off in preparation for the holiday, perhaps. So we're glad to have everyone here. Louis, I'm actually in the office today, so hopefully we get no hiccups from me being out on the road.
Wonderful, wonderful. Well, I'm coming to you from downtown Nashville, where it's a rainy day and getting ready to start. It's been warm. Yesterday it hit 73, but it's going to start cooling off again. And we're going to talk about some of the problems in specifying not only ACM but MCM. We gave it the title ACM for aluminum composite materials, but of course the same sort of panels are faced with other materials: stainless steel, copper, titanium, and I think zinc alloy. And so in the building code they're actually referred to as metal composite materials, MCM. And really everything we say about ACM will apply to both today. It's just ACM, of course, is the most common form. And we're also going to talk a little bit about solid aluminum plate systems that look the same from the outside, but instead of having a plastic core, they are just a solid aluminum plate.
Good. Well, I'm glad you explained what that was, Louis, because I wanted to make sure everybody understood aluminum composite material. We're talking about a panel with aluminum faces and a plastic core of some sort.
Yes, and we'll talk about those cores, of course, in a minute. Now, one of the things that's plaguing all of us is that the manufacturers have not caught up to the code requirements. And so now that continuous insulation is required in almost every climate zone in the country, even into Florida, we now have to deal with installing ACM cladding systems over continuous insulation. But most of our manufacturers, bless their hearts, have not caught up with that and do not even have sample details showing such installations. So and on top of that, because most continuous insulation is foam plastic insulation, that gets us into the NFPA 285 testing. Again, we're going to talk about that in more detail later. But what I want to express right now is that everything's in flux, and so we're going to talk about different manufacturers, and I'm a little reluctant to name names today because next week some of the things I say might be invalid, so we're going to try to avoid that. But if you really think you need to know who I'm talking about, or David is talking about, send us an email, and we're not averse to sharing that information informally, but I'm not sure we want to leave a record of it for the next 3 years on YouTube.
Yeah, because it'll be out of date. And besides, even if we do give you advice or information about it, we'll disavow any knowledge of having given it to you anyhow.
That's right. So Well, let's go to the next slide. And as you saw from the first, we have, kind of three different things. We have the folks that make the individual panels, or maybe I should say the raw sheets goods. And there are basically only 4 manufacturers, I think, in the United States who make them. There are some other nationally known manufacturers who market sheets that are made by the 4 people who actually make the basic panels.
Okay, so Louis, what form?
And I think only one of them actually also makes the attachment components. And then there are I counted about 7 manufacturers of aluminum plate systems.
And when we talk about ACM or MCM, what form do the manufacturers actually deliver their product?
Basically, they're sheets that are 4 or 5 feet wide by different whatever length is that they can manufacture that will meet the fabricator's need to make them into the panels to meet the joining design that the architects have come up with.
Right. So
they are just flat sheets.
Just flat sheets. So that's a really important distinction, that the manufacturer, especially if you're naming manufacturers of the flat sheet in a specification, you're only naming that particular product, not some sort of a fabrication.
Yes, and of course those sheets come in different thicknesses depending upon what wind load or one thing or another. You can get them in different thicknesses, but and they're all metric sizes. And then we have the attachment system fabricators, the people who actually make the components to hold the stuff on the wall. And as I said, I think only one of the manufacturers of base panels actually makes an attachment system that, as is shown here, they're usually extruded systems. And you'll notice that this detail, which I took just this week from one of the major manufacturers of the panels, does not show continuous insulation. It shows the system being mounted directly to sheathing. And of course, if you're just doing an entrance canopy or something like that that's not conditioned, and you may not even have any insulation at all, you can get away with that. But now that we have the requirement for continuous insulation, this won't work anymore.
I sure hope that screw is going into something more than gypboard.
That's all it shows, isn't it? Well, presumably there's a flange of the cold form metal framing stud behind it.
Oh, let's hope so.
We hope so. Okay, and of course that has to be coordinated. And this is what we want to see. It's a smooth, clean, and lightweight cladding system. There's a great movement in architecture to have lightweight products because it saves so much money on the structure. They can go up sometimes faster. People are probably not going to do brick high-rise buildings anymore, or think about how much steel it takes to hold up the 4-inch thick limestone panels on the Empire State Building all the way to the roof. So that's probably not going to happen.
It's interesting you got a really good photo here, Lois, because one of the major concerns we hear from architects routinely is making sure that these panels are absolutely flat, no oil canning. And this photo actually shows a pretty good installation. The center panel that looks like the sun is changing on it. I don't know if that's some sort of an oil canning or if it's just the angle compared to the sun, but it actually looks like a pretty good installation.
Yeah, it does. You're right. And of course, one of the things that we sometimes want to specify is that if there are rather large panels, and these are large, you can see that they are probably on the order of 8 to 10 feet long, that intermediate stiffening ribs may need to be specified and in the fabrication article. Well, let's go on and look at the code requirements. And of course we have the obvious stuff that it has to pass the wind loads by transmitting the forces into the building structural elements. And then we get into the 285 NFPA 285 testing. Now if the building is only one story, you could ignore it. We don't worry about it, even if you have foam plastic continuous insulation, because the code requirement, which I believe is section 2603.5, there is an exception.
That?
Yes.
Wow.
Run into it all the time. That it only applies to buildings of 2 and more stories, because the test itself, the whole point of that test is they're concerned about fire getting into the cavities in the exterior wall construction and going up through the wall to the next and engaging the next floor. So that it's a 2-story test. So if you're a 1-story, you don't have to worry about it. If you're using non-combustible mineral fiber continuous insulation, you don't have to worry about it. Although David has put a little footnote down there that the 2012 version has added this same test if the weather resistive barrier is combustible. So we get into further confusion. And then there's fine. Yes,
Louis, on the foam plastic.
Yes.
I think we ought to caution everybody to realize too that ACM or MCM, because it also has a plastic core, is also falls under this testing requirement, even if there is no foam plastic. As I remember, is that true?
Well, no, I don't think so. The rule of thumb was, before continuous insulation, that you could use the normal panels for buildings up to 40 feet in height, and then above 40 feet you had to go to the fire resistive core. But we'll talk about that in more detail when we get to discussing the cores.
All right. You have one more bullet point here, though. This is an important one that I battle often.
Yes, is that if the coping, one of the things that people like to do with ACM is to make copings out of the same material so that we get a nice clean edge at the skylight. And we'll talk about that in more detail, but the code requires that when they are used for the edge securement of the roof membrane, it has to be tested per the ANSI SPRI ES-1.
Which brings in a whole nother complication to the attachments.
Yes, and Brian Payne has also pointed out that the NFPA 285 is required for ACM installations within 5 feet of a property line. So there are other considerations, but those are the primary ones.
Right.
And we talked a minute ago a little bit about the different types, that there are a plastic core, and then there's the fire retardant core, which of course costs a little more. Now, when I was investigating this and doing research not only for my own firm but also for the presentation that we did on the NFPA 285 testing last year, or early this year, I called the major manufacturers of ACM panels and asked them, and all of them said that their standard plastic core will not pass the NFPA 285 testing. So that means that we're into using the fire retardant core wherever that testing is required. On the other hand, another alternative is the solid aluminum plate of course, is non-combustible, so it can be used. And one of my product representatives who represents a company that provides both ACM and aluminum plate tells me that in many cases the plate is not any more expensive than the ACM, and that because it does resist denting a little better than the ACM, it might be useful to use low down in areas at main entrances or interiors where it's subject to human contact. So that's something that you might want to keep in the back of your mind, is that, and of course you can get them finished the same, so they will look pretty much identical. They're the bends at the edges of the panels, because you have to fold them back, may be slightly different, but most people won't notice, and I won't tell anybody if you don't tell anybody.
Well, there's a way around that too. I mean, the advantage, I think, of the MCM type panels is you can route the back of the panel, so you're only bending the face sheet.
Yes.
So you get a fairly tight corner, but the face sheet is 32 thousandths or less, depending upon the manufacturer. The aluminum plate panel, you get a good manufacturer of the aluminum plate systems. You can also back route the aluminum plate when you bend it, and you can get almost as tight a bend with the aluminum plate as you can get with the ACM. But if you want that kind of a tight corner for aluminum plate, you have to specify it, otherwise you're not going to get it.
Yes, and if you're trying to match the appearance of the rest of the building, that's obviously something that you would want to do.
Right. So the types of systems, though, that we have, whether it's MCM or aluminum plate, we can get basically two different kinds. One's a barrier type, and the other is a rain screen type. So the barrier types are going to have sealed or gasketed joints to keep the rain out at the face of the panel. And the rain screens will have open joints, and there are a variety of designs. They could just be completely open. They could be sort of a baffle with a reveal type plate behind the face of the panel. I know that one of the things that have been coming up too with the rain screens, it was almost as though it was a revelation to some of our clients that, yeah, with the open joints, it's actually possible to see the continuous insulation behind the rain screen cladding. And I just this week had somebody send me a photo, and it looked like they designed the cavity with virtually no space between the cladding and the insulation. So the insulation surface was right out at the joint instead of back in and in shadow. So be aware of it. Be careful if you don't want the yellowish insulation showing through.
Vivian makes the comment that plate run on a different coil coater from ACM won't match if metallic. And I don't have any experience with that, and that very well may be true. Although I think, because the plates are probably sprayed in a plant as opposed to coil coating, if you use the same paint, it should look pretty much the same, but there may be some minor differences.
I can tell you that that's not true from experience, because if you have, when you lay up the painted product, especially in metallics, as Vivian's saying, if you take a piece of coil sheet, like think of an edge flashing, and if you're field forming it and you cut it one and lay it up one way, cut the next piece, turn it upside down, same color, it'll look entirely different.
Well, now that is something, is that of course we all think about grain direction if we were specifying anodized finish or stainless steel or other metal, but there are grain direction on metallic paints, even though they're not very obvious. Vivian has some real concerns. Vivian, can you stick up your hand and actually join in this conversation and tell us about your problems that you've experienced?
Yes, thanks.
Hi, Vivian.
Hi.
Hello.
Hello, hello. So my silver metallic job had ACM panels and a, shall we say, a crazy problem with a expansion joint, a seismic joint that had a big old door, because they really wanted to hide it. So our sheet metal fabricator fabricated a door for the expansion joint, and of course it looked beautiful. It was beautifully fabricated, but it was spray coated instead of coil coated, and there was no way he was going to be able to match the coil coated ACM. And because we didn't order him ACM to make the door out of, there wasn't anything that could be done. And the client, this seismic joint was a pain in the neck anyway for lots of other reasons, because it had to move 3 directions. So it was just one more nail in the poor thing's coffin when it didn't match visually. Because as soon as the sun hit it at a slightly different angle, or because it was spray coated instead of coil coated, the little metallic particles just never reflected the same as the ones next door.
Yeah, and I had a very similar experience, Vivian, and that's why I'm saying the sheet metal, even if you try to do field fabrication, you have to be really careful which direction you're installing, even if it's all coil coated, because turning the direction will make all the difference in the world.
Yeah. It'll
look like 2 different colors.
Yeah, I always warn my architects that if they want a silver metallic job in particular, that when they say that they want their mullions to match their ACM to match that field painted something or other, that they should just go ahead and give that up right now.
Right.
Vivian, you have a question from Rosa, and she asks, was there an issue with different sheen from the 2 coatings?
Yes, that's the whole problem. It's not that the color doesn't match, it's that the color doesn't appear to match because of the different reflectivity from the way that the tiny little metallic particles are oriented. They tend to be oriented in one direction.
And she asked, was one of them a 2-coat and the other one a 3-coat system?
Oh, that I couldn't tell you. I think that they were specified as the same, but because they were applied differently, that they ended up appearing differently. Because a spray will, the particles will all be scattered in obviously non-directional, whereas a coil coating tends to lay them up more directionally, if you will. That's my understanding of it, based on everybody arguing about it for a really long time.
Okay. Well, thank you for sharing all that.
Yeah.
Yeah. Hey, Louis, we had some really good comments too from Dave Metzger. I don't know if you want to pick those up now, or because we're going to talk about those in a little bit.
Well, the coping issue we will talk about a little bit later, Dave, and hope we cover your issues at that time. But he does talk about rain screen systems. If you have open joints, that means that the cavity insulation needs to be UV resistant, since it can be exposed to sunlight. Rather minor, of course, because you have fairly narrow joints, normally usually 3/4 of an inch or so wide, and by the time you return the panels back in, there's not much light that's going to hit them. But what you do need to think about is that insulation UV resistant, and are we going to like the color? Is it too light? I know that Roxol, the mineral fiber folks, they make a dark version of their product specifically for open joint cladding systems.
Well, and I've never had an architect ask me for white. They always want black. They want the joint. No, they want the joints to disappear. So
Yes.
there are a number of options. The colored mineral wool, for one, is certainly an option. There's another one that I saw just recently, and I don't know how many folks have even considered something like this. But foam glass, the black actual glass type board insulation is now being marketed too for cavity insulation. So there's a way to get absolute black insulation
And non-combustible.
To maybe help move us out of this whole issue with NFPA 285, but it also does not give you as good an R value as the other insulations that are available.
And of course, polyiso, many of those systems have a shiny foil surface on the outer side, although some manufacturers make it with one facing that's less reflective. And then of course our friends that make XPS tend to make it in sky blue and bright pink. So that is something.
That could just be for interesting contrast.
Yes, it could. All right, let's go to the next one. Well, so what are the panel manufacturer responsibilities? As I said, all of them will provide sample details, which may or may not be very useful to you. Most of the panel manufacturers, when they warrant their products, will only warrant them against delamination and degradation of the finish. And I only know of one manufacturer who includes the whole cladding system in a total waterproof or water tightness, stay on the building, not blow off, not fail warranty.
Is that the same manufacturer that you mentioned also includes the fastening?
Yes, because they make the whole system, and that's the way they do it. They actually buy panels from somebody else, but they make a system.
Okay.
And only one manufacturer that I know of has done NFPA 285 testing. And most of the manufacturers that I've spoken to, not only of ACM but also of plate, take the position that testing, you have to get the insulation manufacturers to do it. And indeed, some of the insulation manufacturers will list tests, and rather than listing a specific ACM product, they just list that it's a generic fire-resistant core ACM. And that it remains to be seen how the building officials are going to react to that. But on the other hand, ACM is the actual base sheets are pretty much a commodity product like plywood, and it really doesn't make any difference who makes this stuff. Although there is one sneaky thing, though. Let's go back to the code thing.
Oh, sorry. I didn't mean to rush you.
That's all right. That there is one more item that I should have put on here and I didn't, and that is you do need to read the evaluation reports that each of these manufacturers provides, because some of them have some hidden things in there that are cost money. For example, one of the ACM manufacturers, one of the major ones, in their evaluation report from IBC requires that you use 5/8 inch type X gypsum sheathing and type X gypboard on the interior side of the wall. So, got to read the fine print, folks.
Right.
And incidentally, David and I are trying to make arrangements in the early new year to have someone from ICC talk to us about the whole evaluation report process, and I think that will be a really interesting session once we get that off the ground.
Right. Yet to come.
Yes.
Okay. So what is it that you wanted to talk to, going back to this detail again?
Oh, well, just that this illustrates some things that you'd already talked about, the route and return, where they route out the backside of the panel to make it easy to bend, so you can get a real nice, sharp, clean bend. Chuck Coleman asked the question, could we not insulate the composite panel and have that serve as continuous insulation, like H.H. Robertson? And that's true. Insulated metal panels are, of course, just a completely different item, and they're usually at least 2 inches thick, and sometimes 3 or 4 inches thick, depending upon what sort of R value you need out of them, whether it's the only insulation in the wall or supplementary. And in fact, a couple of the manufacturers now make product units that are not decorative in nature that can be used as a backup panel, and you can install ACM over those backing panels.
Right. So they're using that to provide the continuous insulation plus the weather and air barrier all in one product.
All in one product. And that probably would simplify a lot of the issues relating to the NFPA 285 testing, because those guys, Sentry and Kingspan to name two, have done a lot of testing for that in particular.
Yeah, and I would suggest that kind of a system would work well when you have a lot of opaque wall, because the panels you're trying to deal with are limited by dimension. So you're talking about 24 or 30 inch wide panels, and if you're having to do something that's less than that or some oddball module size, you're going to probably pay significantly more for it than standard.
Yeah, it depends upon how many, because you don't cut them in the field. You have to, because they have those special shiplap long edge joints. They have to be fabricated at the factory. But we actually have a medical clinic building going up just within a mile of my office that we designed, that is using that product as a backup, not only for ACM but also for masonry.
Okay.
So,
see, you jumped ahead, Lewis. You already covered some of these points, didn't you?
okay.
So, I look at this and we see stud cavity insulation, and I have to stop and think. One of the very first projects I did that looked at continuous insulation had to have been from the early 2000s. And actually, we had no cavity insulation, and this was for a Penn State project in State College. And when I first saw this, I was absolutely amazed that it was from a design architect coming out of New England. And maybe we really need to stop and go back and look at this whole thing again and really push all of the insulation to the exterior and forget the stud cavity space.
There are certain advantages for that.
Yep, there certainly are. So the design teams really got to take a look at this exterior wall construction, because it's more than just how you're hanging the ACM on the wall, but it's how you're dealing with the fact that you need continuous insulation, and are you having to interrupt that insulation to actually support the cladding. Many of the manufacturers out there are suggesting that the attachment system gets fastened back to Z-girts so that it has some continuous, substantial way of transferring the load back to the building, because if you're using compressible insulation, mineral fiber, for instance, you certainly can't put an attachment system over top of it. Some of the...
But one manufacturer that I know of that has done the 285 testing for ACM systems, they have their own line of continuous insulation. It's a polyiso, and it's dense enough that they can actually connect their system through the insulation to the studs without having to have the Z-girts in between.
So you do have to pay attention to it, and I guess that's really the point of most of this. So,
but other manufacturers throw up their hands in horror at that thought. And then there's the whole question of, if you have Z-girts, does that meet the ASHRAE definition for continuous insulation?
And who's going to answer that question, Louis? Because you and I have tried. You wrote to ASHRAE, right?
Yes.
I called ICC, and the response I got from ICC was, we know the code does not define continuous insulation, but the code also...
referring to the International Energy Conservation Code published by ICC.
Right. So, and they confirmed there is no definition, but the ICC references ASHRAE 90.1, which does define continuous insulation. Correct, Louis?
And I'm going to read that to you.
Go ahead.
This CI notation means that the insulation must be installed in a manner that is continuous and uninterrupted by framing members or other construction elements that would reduce the thermal resistance of the insulation when installed in the construction. Now, does that sound like a Z-girt to you?
It certainly does. So, you know, the whole point of doing the continuous insulation is to isolate the metal framing, especially the stud framing, from the exterior, so that we don't have the thermal bridges between the interior and exterior. So Z-girts...
But on the other hand, I want to share with the folks that talked my firm into buying a special report on high efficiency exterior wall designs from ASHRAE, and I had to pay, I don't know, a couple $100 for it or whatever, and every one of the designs in there shows Z-girts for the continuous insulation. And so I wrote to them and said, that doesn't appear to me to meet your definition, but despite, I think I wrote 6 different emails and received answers to 0.
Well, so we're on our own. So we have to interpret it the best way that we can. And,
right.
And according to the folks I talked at ICC, and of course they won't come out with any kind of a formal response to this, but in a call-in arrangement, they're saying that yes, it is intended to eliminate the Z-girts because it must be continuous, but there's nothing in the code that actually says that.
We have a couple of questions that relate to this this slide. Sheldon points out, look at Cascadia clips. They're used as a standoff for the furring. And those are a wonderful product. They are fiberglass units that you screw to the studs, and they are structural, and then the metal furring goes on top of that, and then you connect to those. The problem is that they can only be used with non-combustible mineral fiber continuous insulation, but they are very effective because they are not thermal bridges. The fiberglass itself is flammable, but you don't have that many of them, and right now the code doesn't require NFPA 285 testing for that product, but look out. Then, I'm sorry, go ahead.
I was going to say, we just got a really interesting comment from Ned Kirschbaum saying that ASHRAE 1365 RP documents the R value reduction resulting from Z-girts. So I was not aware of that, Ned, and if you have any more information about what that would be, I would appreciate you sharing it here with the group.
Yes, I'm going to write that down myself. See, we learn stuff, and that's why we promote interaction here.
Yep, absolutely. All right. So what we wanted to,
And of course, I want to go back just a minute. Steve Laundrie says, are there potential issues if the specification state install is per ACM manufacturer instructions, but the ACM manufacturer that was awarded the subcontract has instructions or details that are inappropriate, like short fasteners? Well, actually, I think that drawing was a little misleading because it just didn't show the studs. Obviously, there was a stud directly behind that sheathing. But in general, the whole point is that the manufacturers are not taking responsibility. Most of the manufacturers. There are some that do. But most of the big name manufacturers that you see advertised in the magazines do not take responsibility for the attachment systems of putting these panels on the wall. And that's a major concern, and that's something that we need to deal with in our specifications.
Okay.
And someone has asked for us to repeat Ned's reference. Ned
okay,
is
you ready?
It's
ASHRAE 1365R as in Robert, P as in Paul. And Ned also wrote back in again to say that it's available on the web. The research was done by Morrison Hirschfield. Reductions are significant and can be as high as 50%. And Sheldon is virtually repeating that. And we saw the same result when you talk about putting insulation in the stud space. It's pretty much a 45 to 50% reduction.
okay. So who is responsible for making sure that these panels don't blow off the building, David?
Not me. Well, the design team has got to set up the performance criteria for sure, especially if we're going to rely on the manufacturer or the system manufacturer who's going to design the attachments. So we have to define what the performance criteria is, what the wind loading is, or the criteria used to determine the wind load, so that they can actually design the system. Okay. So the fabricators, what are they going to do? And I think that we did have a question about talking about shop drawings. Fabricators, we're going to assign them the delegated design responsibility for coming up with the attachments to secure the cladding back to the building system, whether it's stud or masonry, and make sure that that design is signed and sealed by a professional engineer so that we don't have the cladding blowing off of the building and causing damage both to the building or anybody happening to walk by. So the manufacturer is going to be responsible for finding or making all of the attachment components to offer the system, even though he's only buying the cladding probably from another source.
And a lot of these fabricators are regional and local installers.
Yes, they are.
That may not have deep pockets, so to speak.
Right. So they're going to actually fabricate the panels. They'll do all the routing, bending, cutting to size.
And in many cases, you may never have heard of these people before by name.
Right. And there are some out there that have more of a national presence, and you can certainly, through a specification, you can name acceptable fabricators as well as you can name acceptable manufacturers. So if you want to have that level of quality control to work only with select fabricators, you certainly have that within your right to do that.
And this is an area where I think there may be some major changes in the next few years, because these guys are not going to be able to afford to do NFPA 285 testing. But some of the national manufacturers of metal siding systems can do that, which was going to give them a tremendous competitive advantage. And so we may see some major changes in who's actually installing this stuff.
And one of my favorites for quality assurance, when we're talking about somebody that's taking on responsibility of collecting parts and pieces from everybody else and putting them together into a system, I would really like to see that fabricator be the one responsible for actually installing the system to make sure that it's following their design, to make sure that it's going to stay in place.
And a related question from Tommy is, are fabricators typically certified by manufacturers of the base sheets? And the answer is no. They basically want to stay away from that business, that responsibility.
Especially in this kind of a product.
Can we go back one?
Oh, sure. I'm rushing you again. Sorry.
Actually, it was you. You were on this. Let's talk just a second about the fabrication, and remind folks that the four sides have to be folded. So if you have a curved panel, you have to make cuts in those edges and make other special arrangements to do curves. And in some cases, if you have a curved, like a cutout, like we designed a building 3 years ago that had some glazing that had a curved jamb, and it was in ACM, and they actually had to cut a separate piece of ACM. Once they cut the curve in the flat sheet, then they cut a little strip, bent it to the right shape, and then had to have angles and glued it in place with epoxy, and then had angles to reinforce that joint. So,
right. Yeah.
If you're thinking about some curves and things like that, do talk to your local fabricator, because they may be able to help you avoid setting your heart on something that can't be done.
Or you may end up finding that you end up having to rely on a lot of structural silicone to put the system together. Okay. So we're coming up on the hour here pretty quickly, Louis, and I know we have a couple more to get through.
Yeah. Okay. Well, as we've talked before, to date I've only found one manufacturer of base ACM panels who also makes the attachment components. There are, I think, several manufacturers of solid plate panels, it's more than two, who also make attachment components. That's one of the differences between those two basic panel types. And then, of course, there's the whole issue of what is being warranted. And if you read the warranties, as I say, one of the manufacturers states that one of the metal plate manufacturers says that they have a 1-year warranty against failures from defects in manufacturing. Period. So if it falls off the wall, that's not necessarily a defect in manufacturing. They do, even though they make the attachment components, they take no responsibility for the actual installation.
Well, and if warranties are important, and to me, they're sometimes dubious as to whether or not they have much importance. But if they are important, they're usually negotiable. I mean, you can buy anything for a fee as long as you're willing to pay, and you can always negotiate with the manufacturer to get a warranty that you're going to be happy with. It just may cost you some bucks. So that's one option too.
And there is one fabricator who is a national presence who, as I mentioned earlier, although they don't make the base panels themselves, they do the engineering for the attachment system, and if you use their weather-resistive barrier membrane and their continuous insulation, they will wrap that portion of the building in a 10-year warranty, which is actually a pretty good deal.
Okay. Are we done with this one? Can I move on?
I think so.
Okay. Didn't want to rush you.
So this is what we like the looks of, and this brings up the issue that Dave Metzger mentioned earlier in one of his comments. He says, "Well, I like using MCM panels for coping for visual continuity of the facade." You notice that we have a very nice clean line here as the building meets the sky. We don't have a second line of coping like you would see if it was brick or some other.
Are you sure this building has a coping?
This is a detail that I took again from one of the major manufacturers. You all would recognize the name. Just this week, not only and it does not show any continuous insulation, of course, and does it meet code? I mean, people do this all the time, and a lot of folks like to have a curved top rather than this, typical trapezoidal profile that is shown here. Let's go on to the next slide.
Are you going to talk about why this might not meet code?
Yes.
Okay. Go ahead.
And here's why. I actually copied this straight out of the 2012 IBC, and it says that metal edge securement, except gutters, for low-slope roof systems shall be designed and installed for wind loads and tested for resistance in accordance with the test methods in ANSI SPRI ES-1. And none of the manufacturers have ever done that.
Okay.
So,
and if we go back up here and look, right here is the roof securement,
yes.
right?
And it's being secured by this system. So here we have the case of a major manufacturer who is giving you a sample detail that does not meet code. Now, Dave Metzger
is that really an issue?
Well, yes, because the responsibility for meeting code requirements is that of the design team, not the manufacturer. And you wouldn't have much of a comeback against this international manufacturer if you tried to
exactly
involve them in a lawsuit.
You hit the nail on the head, Lewis. It's no concern of the manufacturer because he's only showing the detail that may be able to work to install his product. It is a concern for the design team.
Listen to what Dave says. He says, "I prefer detailing roof edge securement independent of the MCM coping. This is primarily so as not to involve two different trades, MCM and roofing, in the installation and the warranty of the roofing system. I prefer having only the roofer responsible for the roof system, for the roof system installation." And that makes a lot of sense. It's
a great approach.
Basically, you need to tie off the roof membrane independently. Now, that's not to say that we might want to put some other waterproofing membrane over the top of that parapet wall construction, as is shown there with the dashed line, but that's not the securement for the roof membrane as such.
Right.
I don't know how widely enforced that is by the building officials, but it's there in the code, and we ought to do it. Especially if you have a problem, it's going to blow up. We don't want it to be a problem.
Exactly.
And of course, remind our detailers not only to provide drips at the soffit edges so that we don't get this unsightly staining, but also to provide, you notice that there's no soffit vents shown here, and unless that's insulated all the way around, which I doubt, you can get, of course, it'll act as a humidity chamber, and you'll get condensation building up in there, and could cause rusting of the steel supports or other damage. And so
Right.
you have to ventilate those unconditioned spaces.
This is a great example of what happens with those horizontal rounded edges like this, where the water just follows the edge around.
This is a hotel that's, I don't think, 2 years old, maybe 3.
Yeah,
at the
and
most.
there's no way to prevent the staining on the bottom surface of the round edge because the water's going to run and follow it.
And the janitor ain't going to clean it.
Right. Okay, so Louis, we're at the end, yes?
I think so.
And we're right on the hour, too, so perfect timing. Do we have any other questions left that we didn't address?
No, Elias asked, was that coping design or one like it, has it been tested and failed? But the point is it has not been tested. Now, in addition to the, just very briefly, there are, of course, manufacturers of coping systems who have had all their systems tested. The NRCA also has a program where they have certain designs for sheet metal that are tested, and then there's a certification process for the local sheet metal shop, and that they can even apply a seal or a label to the coping that says that it complies. But I don't know of any such arrangements for ACM copings, and for one, partly because they just vary so much in design.
And because you're relying on a fabricator to actually create the coping as opposed to purchasing a manufactured system.
Right, or having a local registered sheet metal shop do it.
Right.
Because that's different from the guy that's making the ACM panels for the main cladding. Anyway, well, I hope we didn't confuse anybody too badly, and just, you know, we're a little frustrated, David and I ourselves, in terms of how to deal with this. And if you guys get any good ideas, be sure to share them with us.
And we'll see you in a month.
All right. Thank you, everybody, for attending this month's Specifying Practice Group. You may now disconnect and look forward to seeing you at the beginning of next year. Bye, everyone.